Okay, I want to start off with an example from the last unit. How would we solve something like this? Well, pretty easy. We have something squared on this side, and we're trying to get the x by itself, so we can take the square root of both sides. When we do, this would just be x minus 5, and we'd get plus or minus the square root of 49, which that's really just 7. And then we could add the 5 to the other side, and we get x equals 5 plus or minus 7. That means we have 5 plus 7, which would be 12. Or we'd have 5 minus 7, which would be negative 2. Now that is a really easy way to solve things. We've also been looking at the vertex form of a quadratic, and it's so easy to graph. So there's a lot of times where getting it into this form where you have something squared makes it a lot easier. Let's look at one. What if we had x squared minus 8x plus 16 equals 25, and we're asked to solve that? What if we tried to make this look like this? Well, let's see if we can factor that left side. X times x, and then negative 4 times negative 4. We end up with x minus 4 squared equals 25. Now we have a problem just like we had up there. Take the square root of both sides, and I get x minus 4 equals plus or minus 5. Square root of 25 is plus or minus 5. So I'll get x equals 4 plus or minus 5. That's x equals 9, or x equals negative 1. So we end up with these two options. Now I really want you to think about what it takes to have something squared. Like if we had x minus 5 squared, what that would have looked like to begin with. That would have been x minus 5 times x minus 5, which is x squared minus 10x plus 25. If it had been x plus 2, x plus 2, x plus 2, we'd get x squared plus 4x plus 4. X minus 3 squared. That's x minus 3 times x minus 3. We would get x squared minus 6x plus 9. I hope you're noticing the pattern here. This number is half of the middle term and the square root of the last term. So let's see if we could find the missing numbers that would make a perfect square. So what would it take to make this be a perfect square? Well, we have to kind of think about what we're wanting it to be. Whoops, I didn't mean to do that one. I meant to do 14 there. X squared plus 14x plus something. We want to make that to be something squared, a binomial squared. Well, if we're noticing the pattern, the number in there is going to be half of that. So the missing number here would be x plus 7. But that means this one would have been, if you look here, negative 5 squared is 25. 2 squared is 4. Negative 3 squared is 9. So 7 squared is 49. What about here? X squared plus 22x plus something is going to give me a perfect square. This is going to be x plus half of that middle term. This is going to be this number squared. What if we had x squared minus 26x? These are some big numbers here, but it's okay. Over here, we'd have x, and then half of that, negative 13, take that number and square it. That's 169. So think about this. Remember, this number is coming from half of that middle term. And we can even do harder ones. It's okay. What if this had been negative 9x? And we're trying to figure out what's missing and what perfect square it would be. Again, this is always going to be half of that middle term. So what is half of negative 9? Well, half of negative 9 is just negative 9 over 2. Now, what happens when I square negative 9 over 2? So that, and I'm going to call it c because that is the ax squared plus bx plus c. C is going to be that negative 9 halves squared. So when I square the negative 9, I'm going to get 81. And I square the 2, I'm going to get 4. Even if it's a fraction, it's still okay. Don't freak. What about 7x? So in the parentheses, we're going to have half of that middle number. That'd be 7 halves. Square it to get here. So 7 squared is 49. And the 2 squared is 4. You're done. Now let's see why that would be useful. There's two main reasons why we would want to use this. One reason is for solving equations. So let's look at some of those, and then we'll look at changing quadratics from standard form to vertex form. So the first thing we're going to look at is solving by completing the square. This is what this is called. So let's say I have x squared minus 12x plus 4 equals 0. Now, in all of these, I just had the x squared plus the bx right there. That's what I want. So I'm going to move that 4 over just temporarily. So that would be a negative 4 over here. Now I really want to think about, we want to make this be something squared. Right? Now we have to find something that we can add here, or some, well, actually it's going to be add, that we can add here that would complete the square. So like what we're filling in the dots here. Whatever we add here completes the square. But remember, this is an equation. We have to keep it balanced. So we're going to add it to the other side as well. Now, what do we want the binomial to be? It's always going to be x and then half of that middle number. That means that whatever's missing here is this number squared. So what's negative 6 squared? Well, that's 36. So we're going to add 36, add 36. These are equivalent. If you're not sure, check it out. Take x minus 6 times x minus 6. I guarantee you'll get x squared minus 12x plus 36. On the right side, the negative 4 plus 36 gives me 32. Now I have a nice and pretty problem. I'm going to take the square root of both sides. The left side will be x minus 6. The right side is going to be plus or minus the square root of 32, which I know that simplifies. That's going to give me plus or minus 4 root 2, and that's because the square root of 32, the square root of 16 times 2, the square root of 16 is 4. Add 6 to both sides, and I get 6 plus or minus 4 square roots of 2. Nice, huh? Let's look at another one. So another one where we're solving. 2. Oh, let's do this. Let's put something in front of the x squared. It doesn't matter. I'm going to divide by it anyway. I'm going to divide both sides by the 3. Divide this side by 3. Divide that by 3. And I get x squared minus 12x plus 50 equals 0. X squared minus 12x. I can't believe I used the same one. That's okay. Subtract 50 over here. I didn't mean to use the one that has the same middle term, but at least we know what it's supposed to be. Since we did on the last problem, we know this is supposed to be x minus 6 squared, which means that to complete that square, we're going to have to add 36, add 36. It's okay to make mistakes. This time it made it easier on ourselves. Negative 50 plus 36 is going to give me negative 14. I'm going to take the square root of both sides and get x minus 6 equals, don't forget the plus or minus, square root of 14. Can 14 simplify? Whoops, I forgot the negative. That was a negative 14. Oh no. What do we do if we have a negative number under the radical? Just take an I out. That's going to be 6 plus or minus I square roots of 14. And you're done. Now let's look at one where we're converting to vertex form. This is going to be very useful. Okay, so convert to vertex form. So let's say I have y equals x squared, this would be example 3, x squared minus 10x plus 22. Well, we're going to start off with the same idea. I'd rather just deal with those terms together. So let's move the 22. Move it to the other side as y minus 22. I'm going to leave myself some space and you'll see why in a second. X squared minus 10x. Now, I'd like for this right side to be something squared, right? Well, what's it missing? What do we want this to be? X, and then half of that, so minus 5. But what are we missing for those to be equal? Because right now they're not. What I'm missing is that number I put in the parentheses squared, plus 25. This would be plus 25. So y minus 22 plus 25 is going to give me y plus 3 equals x minus 5 squared. And then we're just going to get the y by itself. And look at what we know now. Do we know our vertex? Right off the bat, we know our vertex is 5, negative 3. Now I'd like to do one that has a coefficient here as well. I'm going to have to make up one, which may not come out too pretty, but that's okay. Let's say I have y equals 3x squared plus 5x minus 2. All right, I'm just going crazy with this one now. This is probably one of the hardest ones. Now I could go ahead and start off by adding the 2 if we wanted to. Y plus 2 equals 3x squared plus 5x. But I want you to notice something here. We don't want that 3 in front. Have we had to deal with that before? No. Well, how about a divide both sides by it? It'll be y divided by 3 plus 2 divided by 3 equals 3x squared divided by 3 is just going to be x squared plus 5/3 x. So I'm doing a really good one here. Okay. I want this to be something squared. I know this is going to be an x. And I know this is going to be half of 5/3. But if I take half of 5/3, that's really 5/3 times 1/2. So that's 5/6, right? Half of 5/3 is 5/6. So now I get an idea of what I'm going to have to add to both sides. I didn't leave myself much room there, so I'll add it right here. I need to take that 5/6 and square it. So if I square 5/6, 5 squared is 25, 6 squared is 36. So I'm going to be adding 25 over 36 to both sides. So right now we've got the y over 3, right? 2/3 plus 25, 36. 2/3 plus 25, 36. We have two fractions. They need a common denominator. Let's make it 36. To make that 36, I need to multiply by 12. So 2 times 12 is 24. And then 25. Whoops. So 24 plus 25 is going to give me 49 over 36. Now, we're going to try to get y by itself again. So, like up here, we move the 3 next. I'm going to move this constant next. So I got y/3 equals x plus 5/6 squared minus 49 over 36. Now, we still want to get y by itself. To get y by itself, I'm going to need to multiply both sides of the equation by 3. So that means I'm going to have to multiply y over 3 by 3. I'm going to need to multiply this by 3. I'm going to need to multiply this by 3 as well. Here the 3's divide out, and I'll be left with y. 3 times that parentheses is just going to be 3 times the parentheses. And then 3 times this. Now remember, 3 times 49, 36, kind of like having 3 over 1. 3 into the 36 will go 12 times, so I'm going to be left with 49 over 12. Ugly, but hey, it worked. That means my vertex is at negative 5/6, negative 49/12. Ugly, but it works. Now, if you want to check out one of the other videos, you can see how completing the square was used to prove the quadratic formula.